Hello student. Today's topic completely randomized design, in short CRD. The simplest and most flexible design in the completely randomized design. In this design, the experimental unit are allotted at random to the treatment so that every unit get the same chance of receiving every treatment. In addition, the unit should be processed in random order at all subsequent stages in the experiment, where this order is likely to affect the result. Also, in the design, treatments are allocated at random to the experiment unit over the entire experimental material. Let us suppose that we have a V treatment. Okay, we have a small V treatments. The ith treatment being replicated Ri, it's Ri terms where I equal to 1 to 1 to dot v 1 to dot v. Then the whole experimental material is divided into small n equal to summation Ri. Experimental units and the treatments are distributed completely at the random over the unit subject to the condition that the ith treatment occur Ri terms. Randomization assures that extraneous factors do not continually influence on treatment. In particular case, if Ri equal to R I, where I equal to 1 to dot v, that is, if each treatment is repeated an equal number of times R, then small n equals to Rv, and randomization gives every group of R units an equal chance of receiving the treatments. In general, equal number of replication for each treatment should receiving the treatments. In general, equal number in particular case when some treatments are of greater interest than other, or when practical limitation dictate otherwise. Also, a table of random numbers is to be used to assign the units to the treatments. For instance, suppose there are V treatments to be compared and we have n experimental units available. Let the ith treatment be replicated R1 times so that small n equals to summation I Ri. The treatments may be numbered arbitrarily from 1 to V and the experimental unit from 1 to n. R1 unit selected at random from the n unit using a table of random numbers may be allocated to the first treatment, and R2 unit selected randomly from the remaining unit to the second treatment, so on. Now we are discussing about advantage and disadvantage of CRT. Advantage of CRT. Okay, advantage. Now CRT has several advantages explained below. Okay, so the first one, it is easy to lay out the design. Okay, the second one, it results in the maximum use of experimental unit since all experimental material can be used. The third one, it allows complete flexibility as any number of treatments and replicates may be used. The number of replicates of desired can be varied from treatment to treatment. Number 4. The statistical analysis is easy even if the number of replicates are not the same for all treatments or if the experimental error differ from treatment to treatment. Number 5. The relative loss of of information due to missing data is smaller in comparison. I repeat, the relative loss of information due to missing data is smaller in comparison with any other design, and they do not pose any problem in carrying out the standard analysis data. Number 6, and this is the last one, it provides the maximum number of degrees of freedom for the estimation of the error variance, which increases the sensitivity or precision of experiment for small experiments, that is for experiment with small number of treatments. Now we are talking about the disadvantage. In certain circumstances, the design suffers from the disadvantage of being inherently less informative than the other more sophisticated layouts. This usually happens if the experimental material is not homogeneous. Number 2, since randomization is not restricted in any direction to ensure that the unit receiving one treatment are similar to those receiving the other treatment, the whole variation among the experimental units is included in residual variance. This makes the design less efficient and result is less sensitivity in detecting significant effects. As much CRT is seldom used in field experimentation, where due to fertility gradient of soil, the whole experimental material. Okay, where is the problem? A set of data involving 4 tropical feedstuff A, B, C, D tried on 20 chicks is given below. All the 20 chicks are treated alike in all respects except the feeding treatments, and each feeding treatment is given to 5 chicks. Now analyze the data. Now the solution is null hypothesis A0 such that tau A, tau B, tau C, tau D. That is, the treatment effects are same. In other words, all the treatments A, B, C, D are alike as regards their effect on increase in weight. Now first, alternative hypothesis. Let H1 at least 2 of taus are different. So raw SS equals to summation I summation j yij square equals to 55 square plus 49 square plus dot dot 85 square plus 154 square, that equals to 181,445. Now correction factor called CF equals to G square by N, that is 1695 whole square by 20, that is 143651.25. So total SS equals to RSS minus CF, that is this minus this, that's equals to 37,793.75. So treatment SS equals to T1 square, T2 square t3 square plus t4 square by 5 minus cf equals to 47,961 126,025 plus 165,649 plus 509,796 divided by 5 and minus 143,641.25. So error SS equals to total SS minus treatment SS, that equals to 37793.75 minus 26234.95, that equals to 11558.80. Okay, now we draw a table. Source of variation. SS DF MSS, which equals to SS by DF. Variance ratio capital F. Now treatments. Error 26234.95 and 11558.80. Here 3, it's 16. 8744.98 and 722.42. Ft equals to 8744.98 722.42 equals to 12.105. It's 19. 37793.75. Write it total. Okay. The next test statistic. Ft 316 tabulated. F 05 316 equals to 3.06. Hence Ft is highly significant and we reject H0 at 5% level of significance and conclude that the treatments A, B, C and D differ significantly. Since H0 is rejected in the case, we proceed further to find out which of the treatment means differ significantly. For this, we find out the critical difference, that is, the least difference between any two means can be significant. AC of the difference between any treatment, that means C dot D equals to root over 2AC square by R. T 0.025 for error D dot F equals to root over 2AC square by R. into T16 0.025. So root over 2 into 722.42 divided by 5 into 2.12 equals to 16.99 into 2.12 equals to 36.018. The treatment mean effect arranged in descending order of magnitude are given in this table. Now at first we draw the table. Here write treatment. Mean gain in weight, and here difference. Now D, C, B, A 142.8, 81.4, 71.0, 43.8, 61.4, 10.4, 27.2, that is 37.6. Comparing this difference with CD, we find that treatment D differs significantly from each of the treatments ABC. The treatment A and C also differ significantly, and all the remaining difference are not significant. Now the conclusion is treatment A, B, C, D are not alike. The second one, the highest treatment mean effect is 142.8 due to Fettstaff D. And the third one is, hence if a choice is be made among the 4 treatments A, B, C and D, treatment D is the best and most effective. Moreover, if a choice is to be made between A and C differ significantly, the treatment C is to be preferred since the average gain in weight due to treatment C is more than due to treatment A. All other possible combination of treatment pairs are alike.